All right, this is ITS128. It is January 22nd, and it's like class number 5. And this is the 5th class, and I guess today we're going to start chapter 3. And so let me switch to my. Let me share the screen here. And let me, if you're calling in, mute yourself. So let me put this down here. All right, so we are right here. We're going to start chapter 3. And so let's open up some. Let's see what the PowerPoint slides look like. Do I have them? Let me go here, here, here. Do I have chapter 3? No, I don't. Okay, so let's go here, download chapter 3. And I'm going to put them here. And let me open this up. I don't think I have a new assignment for you yet. I'll get going into chapter 3 a little bit before we start a new assignment. All right, so in this chapter, we're going to start to learn more about processing data, assignment statements, and so on. So we're going to learn how to read and write text boxes. We're going to look at variables, understand data types and variables, how to perform calculations, and outputting, formatting, exception handling, which means how to handle it when the user enters in something funny or your program does something funny. It used to be that if you did something funny and your program bombs, there's nothing you can do about it. So you went through great lengths to write code to make sure that everything is correct before you do a calculation. Like, for example, you can't divide by 0. So in the old days, you had to go through these checks to make sure that that didn't happen. With these new programming languages like Java and C#, you can add what's called an exception handler, and it catches errors. And so it catches an error instead of bombing. It catches the error and then returns control back to you, and you can display out an error message or something and give the user another chance to enter in data. Or if you try to divide by 0, an exception is, they call it they say an exception is thrown and the computer doesn't do it, and then you're able to go off into some other part of the program and execute some stuff to recover from the error. And then we're going to talk about named constants. You'll learn more what that means. Declaring variables as fields. It's declaring variables, but it's declared in a little bit different way. And using the math class. The math class has all these methods in there to do rounding and sign and all kinds of math functions. More graphical user interface details, and using the debugger, how to debug your code. So reading, input, and the text box control. There's a text box. Let me just pop open Visual Studio here just so we can. While this is coming up. Let me just sign in here. I have to sign in. Start a new project. So you know a text box is just a box on the form that you can type text into, accepts keyboard input. It's located in the common control group of the text of the toolbox. You double click to add it. You can drag it if you want to. You can click and click if you want to. And the default name looks like this. And so we're talking about, let me just, while we're at it, pop open a new project so we get that up here. It's a Forms, Windows Form application. I'm just going to pop this on the desktop. So here's a form. We can click on this toolbox tab over here on the left, click, and then we can click on this little pin here, right here, to pin it over to the side here so we see both this. And we see this category here called Common Controls. Click that open, and here are a bunch of controls, common controls. And here's text box down here. So you can add a text box to the form by either double clicking. Right, here's one. You'll notice the name of it is, go over to the properties and you see the name is text box 1. Or you can also drag it over, and you notice now this one's called text box 2. Or you can click and then go over to where you want it and go click, and that's you know, it says text box 3. And just to let you know right now, I prefer the naming convention where we would call this maybe something like TXT box 1 or something. Anyway, we'll get more into that later. The text box controls a text box controls text property. The text box this doesn't make sense at all. The text boxes control the text boxes text property stores the user's inputs. The text property accepts only string values, except everything's a string. This is a way to assign a text box text values to a value. Excuse me. So if you were to execute this as a program statement, after it executes, it's going to have the word hello in the text box. This is how you empty it. So basically what we're saying here is let me double click on the form itself, and it pops this up. I'm going to make this bigger. And so we can do txt, there it is, textbox dot text equals hello there ITS128. And when we execute this, it goes, there it is. Hello there, ITS128. Isn't that cool? So anyway. And then you can blank it out again. So I'm going to, so I can show you that later, because I haven't shown you event handlers or anything yet. Okay, so first look at variables. A first look at variables. A variable is a storage location in memory. The variable name represents the memory location. In C#, you must declare a variable in a program before using it to store data. Notice it says C#. It's because variables have to be declared before you use them, and their type must be defined before you use them. So the syntax to declare variables is, this is the data type, such as int for integer, string for string, double for a double number, and so on. And this is variable name. This is spelled wrong. It should be variable name, not variable name. So you do something like string Joe variable, whatever, equals 1, 2, 3, 4, 5, semicolon, and then you can say TextBox2 dot text equals Joe variable, semicolon, and then when we run it, it goes like this. There's TextBox2.
So the string is what in a way strings it all together. So.
Mm-hmm. Yep.
Can you use it one?
Yes, you can. Yep. And we can do all kinds of stuff. It's fine. We're real basic here. The data type specifies the type of the variable a variable can hold. So there's int, so on. You cannot do int Fred equals 1, 2, 3, 4. Or you can't. Joe Blow. That doesn't work because you're saying Fred is an integer and you're trying to write a string into it. Look at that. It's even telling you right away. Cannot implicitly convert type string to int. It's basically saying this is a string and you want to store it into an integer variable, which can only store whole numbers. And so you must be trying to implicitly change the type, but you can't implicitly change a string to an integer. It just doesn't work. This is where this is the syntax error. It doesn't let you go any further. And what's nice about Visual Studio is as you type it in, it's checking the syntax of your. If there's a what's great about Visual Studio is it's always looking for errors. As soon as it determines that you've typed in something that's wrong, it tells you right away. It's really a time saver as far as that goes, which is one reason why Visual Studio is a lot of programmers don't like Visual Studio because the learning curve is really steep. They say it's clunky, it's all this stuff. But I tell you, once you get over the hump of learning Visual Studio, then you're a lot better off. You're much better off working in large programming settings and so on. Yes.
So if there are some holes in Visual Studio, there could be other options.
Well, yeah, there's Eclipse. There's a bunch of other ones there's a bunch of other ones, but and they're all pretty good, but none of them are quite as good as Visual Studio. You have to pay for Visual Studio. I mean you don't have to pay for the community edition, but if you want the professional edition or the enterprise edition and you're not a student, you have to pay. Whereas all the other ones are free. We at KCC we have declared ourselves a Visual Studio shop, if you want to call it that. And you notice in the course descriptions it says Visual Studio, and so that makes us kind of special. So a variable name identifies the variable. Always choose meaningful names for variables. Fred and Joe variable are not meaningful names. You would use something different. More indicative of what you're going to use it for. Basic naming conventions are: the first character must be a letter or an underscore. It considers an underscore a letter. And the name cannot contain spaces. And and do not use C# keywords or reserved words. So, for example, string is a key word. So don't go. I don't think this will work. Int string equals 5. Oops, forgot to put the semicolon. Okay, no, it doesn't work because this is a so-called reserved word. So you have to do something like that works. Now, why is there a green squiggly? Because you've declared a variable and you haven't used it yet. So if you go Fred equals string plus 2. Notice the squiggly line goes away because now you're using it. So Visual Studio is so smart where if you declare a variable and you never use it, it thinks there's something wrong. Probably you misspelled it, or maybe you've declared it previously a slightly different name or something. Or maybe you declared a variable and you use it and everything, and you write a bunch of code and you use it, and then later on you go in and you change your code, you change a bunch of code, you replace a bunch of code with some other code, and then you end up not using the variable anymore. So you got this variable declared, taking up space and all this and that, and Visual Studio says it's not a fatal error. The program will still run, but it'll put that green squiggly under there saying, are you sure you want to keep this here? Okay, they're string variables. Let's talk about string variables. They're a combination of characters, and by the way, digits are characters. A variable is a string data type, can hold any combination of characters, such as names, phone numbers, social security numbers. The variable is assigned on the right side, using the equal operator and the expression on the right. The variable's on the left. The variable name's on the left. The expression that is evaluated, and then the result of that expression evaluation gets stored into the variable. Now, this is simple. This is just this, but if you wanted to do something like a string product description equals, what is it, product description, Italian espresso machine. So if you do Italian space, so this is an expression, oops, plus espresso machine. TextBox 3 equals product description. Oh, build errors. So let me, I never fixed Joe Blow, so let's fix Joe Blow. I want to say string. That fixes Joe Blow. Now the problem here is that I'm trying to assign this string value to the text box itself. That doesn't make sense. You assign it to a property of a text box. Not in the text box 3 is an object. It's got a bunch of, it's the, I'll show you. Text box 3 is this. It's got a bunch of stuff. It's got all this stuff. The TextBox 3 has got a bunch of properties. It's got a location property. It's got a name property. It's got a size property. And the text property is not here because that's something that's assigned when the program's running and not when the program is being initialized. So we actually want to say the property, the text property. And what's the matter with this? Oh, Fred's of that. Okay, let's make this a quote. Wait a second. I shouldn't need this. Oh, I guess I can't implicitly convert an int to a string. So I guess I got to put this in quotes. Okay, so I'm going to run this because I want to see what this turns out to be. Let me make it. First of all, let me make it bigger, 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 and I also want this text box 3. Let's make it so it's 18-point font. Let's make it bigger. Now when we run this, look, you notice there's a space there, but there's no space there. Well, why? Because that's how I programmed it. Look, I put a space here, but I didn't put a space here or here. So when I concatenated espresso machine, it just stuck them together and didn't put a space in between. So that's the kind of stuff you got to pay attention to when you're writing programs. So here we're assigning a label. Wait, this doesn't. Assigns the product description to a string label named product label. No, this doesn't work. It's got to be there's a text property. This book is bad. Slides are bad. Here, let's try it. So I'm going to put a label on there. Here's a label right there. I'm going to make it bigger. Make it 8. And so it's called label 1. And so if I go back over here and I say label 1, label 1 equals product description, well, it's not going to work. I'm trying to do that. Oh, product label. Let's name it product label. Well, anyway. So it's got to be text. Almost every control has got a text property. I mean, the form has a text property. It's right there. Oops, right there. Buttons have a text property. The word that appears on the button, that's the text property of the button. All right, let's not fool around here. And this is how you can display a message box. So this is a very nice thing to know because we can just display stuff up on the screen. Message box dot show parentheses product description. So when we run it now, it goes boom. Italian espresso machine. See that? Right there. Okay. Concatenation is the appending of one string to the end of another string. I've shown you that already. See, this is hello world, creates a, this is wrong also. look, this is capital and this is lowercase. This isn't going to work. Wow. Boy, I wonder who, you know these, I've noticed this teaching. The answer keys. The answer keys. There's at least 5 errors in. These writers of the textbook, the publishers, they give you all this extra stuff for instructors to make our lives easier, but they don't make our lives easier. Well, they kind of do. You have to look at every one. So I used to think, well, maybe what they're doing is they know that students are going to get a hold of the answer key somehow, so they put errors in there on purpose, and the students won't know, but the instructors should know. Well, the instructors have to know that they do that, because otherwise we're just gonna use them. And so I used to think that, but now I just think they got some graduate student doing it, and the graduate student's got other things on his mind. He's got exams and qualifying exams to get all this kind of stuff, and then they just are lazy. Yes.
So I think maybe a solution to that might be like opening up all of this question, like all of what we study, all of the materials,
Mm-hmm.
and having many universities, many graduate students look over it and improve.
Yeah. However, but what's the process for that? How do you get that information? Yeah. Well, okay, it's possible this is a brand new set of slides, and there's other things possible. Maybe when this thing was written, it had the autocorrect thing where it automatically capitalizes the first letter of a sentence or something. So we end up with something like this. But it is case sensitive. So like if I were to try to put this on here, I do string message equals whatever. Do I set it equal to something? Yeah, no, it's not. You don't say, if you don't have to declare it. And then I say message equals hello. Oops. Plus world. See, it doesn't let me, because this is different than this. It says, oh, look, green squiggly, you're not using this variable that you've declared. And then here it says, hey, message, you haven't declared this yet. Concatenation can happen between a string and another data type. You should be able to do this. Except I don't know why this other thing didn't work. I don't know why this. I don't know why that didn't work. How about 2.5? Can't implicitly convert a double to a string. This is. Let me try this. That works. Oh, it didn't work before because string underscore was an integer, not a string. That's why I did. So I can do this. Fred. Oh no, Joe variable. No, well, anyway. Fred equals product description. That works. So here we're implicitly converting this to a string before we concatenate it onto this. And we can do 2 also. So here we're taking, we're going to stick 2, 3, 4, 5. We're appending it to that, and then we're going to display it out in this third text box. So if we run this now, forgot about this. I'm going to append hello world on the end of label 1. So I'm going to do equals label1.text plus message. So I've taken label, so a label field, you can either write into it and you can read it back out again. Here I'm reading it back out again. So when I do this and I run it, it does that, because that this is the result of this product description right here. Oh, I'm not writing out Fred. Shoots. Oh, here I am. Oh, label 1. Okay, I'm taking yeah. Anyway, so here I've added. Oh, here, let me make this be Fred. There. Anyway, it's not super necessary that you actually type this along with me and see it, but if you want to, you can obviously you can watch the video later. All right. So you need to declare a variable before you use them. Of course, you can declare variables and use them later. So you can declare a variable way at the top, and then you can use it way down later on, just as long as you declare it first. Declaring it allocates space in the memory of the computer. So you have to allocate the space before you use the space. Okay, there's this concept called scope. And when you declare a variable has scope, has a scope. And what scope means is it's where the variable is actually a valid variable and can be used. So we say, is this variable in scope or out of scope, or is it? So, for example, here, if we declare a variable out here, string, I'm going to call it class variable, equals this is a class variable. Okay, so I've declared a class variable out here, and then I'm going to declare inside here. Oh, by the way, have I explained what a load handler is? If I explained why this works, why I'm able to put all this stuff in here and it does something, let me just quickly just quickly show you that. Okay, so when the program starts up, this thing runs, and the first thing that happens is it sees if the form itself has what's called a load handler. And by load handler, it means when the program loads, it executes a little method. It executes a little program. It's a program that handles the loading of the form. And so the loading of the form is the code, the program, which executes right when the form is loaded up. It's called the load handler. And the way you get to the load handler is you double click on just the form itself. So I double click on just the form itself out here, and this is the load handler, this code right here. And so I've put all of these program statements inside the load handler. And so that means that as soon as I run the program, the load handler is going to execute, and all this code executes. So that's why as soon as the program comes up, that's why you immediately see this message box here, which displays out the product description, which is that little window that comes up. And then after you click the OK, it goes and finishes loading. See, this is inside the load handler, so this happens as the form is loading. And once this load handler is finished, then the form appears, and then all this other stuff. You see all this other stuff. You see this stuff in the text box and everything. So what I've been doing now is a real good way just to test to see if your stuff works or that your thinking is right about something. Just try it out. Whip up a little program, throw some statements in there, and just see if it works. And they're little dinky programs, so if there's an error, you should be able to figure it out right away, and so on. And so it's not really necessary that you remember everything. It's not really necessary that you have your textbook with you when you're trying stuff. If you sort of know, if you have an idea of what you're trying to do, you can just whip up a little program and try it out and change it and stuff until it works. But anyway, so a variable that's declared out here, like this one, is also accessible inside here. So if I say, so let me, instead of this label, where's a label? Here's this product description label. Instead of the label 1 product description, I'm going to say class variable. And so label 1 is going to have class variable in there first. And then after that, it's going to tack on this message. So I'm going to put a space there just so. So now when I run it, we see this is a class variable, hello world. So now, but a variable declared inside here is not visible outside here. We have, if we have another so-called event handler, I'm going to throw a button on here, and I'm going to double-click on the button. This is the event handler for when you click on the button. So if I go string button event handler, say, oops, I got to name it. I'm going to say string button string, just for lack of a. So I can say button plus this. So so now when I click on the button, it's going to execute this event handler, and we also have access to this. So let me just be stupid here, and I'm going to do plus class variable. Okay, so this is this. This button string is this button string. So when I execute this, and I have this, I click on this button, it says button handler, this is a class variable, you clicked on me. Button event handler, this is a class variable, you clicked on me. Now, but this string was declared down here. It is not accessible up here. I mean, I cannot put plus button string because this button string variable is only it only exists in this. The scope is just this event handler. It's inside this. It's not out here. If button string were to be declared out here, then it would work. If I go like this, watch this. I'm going to put this out here. I'm going to say class variable. I'm going to put this one out here, and I'm going to put this one in here. So now you notice there's no squiggly there. So if I execute this now, we see, class variable, hello world, button event handler class is saved. Oh, because see this button event handler, but inside here it's still button event handler. Out here it's button event handler class variable. Okay, so the point is, wondering what's the point? This button string is the class variable. Okay, it's defined down here. It's defined down here, but it's okay because it's in the outside. This is inside. So if you declare something on the outside, it's visible on the inside. But if you declare something on the inside, it's not visible on the outside. And inside here, since we have a variable inside here called button string, now what's inside here cannot see this anymore. Can't see it anymore because it's been like overwritten. It's like you try to use button string in here, it's going to use the nearest button string that was defined. It's not going to use the one out here. Now, just as an aside, the reason that you can declare this down here and this up here, what's the reason? Well, when the program loads, this whole thing executes, okay? Now, when this whole thing executes, okay, this executes, this does not execute. No, I'm sorry, this does execute. Okay. So when this program loads, the first thing that happens is all the class stuff executes. Okay, so all of the assignment statements in the class execute, and these are all just definitions. This is a definition, and this is a definition. When the program begins to load, I'm going to say that again. When the program starts to execute, then this executes, and this executes. And this is processed and gets ready to execute, and this is processed and it gets ready to execute. Now, but this is an actual event handler. This doesn't execute until an event happens. And this doesn't execute until an event happens. The event that causes this to execute is the loading of the form. So first everything executes, and then the events are processed, and this executes. This actually does not execute until somebody presses a button, and the program can execute start to finish, and no one presses on the button. That means that this will never execute. Anyway, I'm getting kind of ahead of myself here. So the rules of variables: you can assign a value to a variable only if the value is compatible with the data type, and we sort of saw that. This should work because we're going to implicitly convert this to a string. In C#, the variable must be assigned a value before it can be used. You can initialize the variable with a value when you declare it. See here, we are We're declaring the variable and we're initializing it. We don't have to initialize it when we declare it. We can just declare it, and later on it gets assigned a value. So here we can initialize, or we can declare 3 variables all in one line. It doesn't assign any values to them, but it allocates the space in the memory for them. If you need to store a number in a variable and use the number in a mathematical operation, the variable must be of a numeric data type. So we have integers, and the values for integers can range from this value to this value. It's 2 to the minus 31. No, minus 2 to the 31 to plus 2 to the 31. It can be a double number, which is a real number, which includes fractional parts. Here we're assigning it a value. Here we're assigning it a value. And in this case, when you're talking about numbers, you don't put quotes around them. We have decimal types here, and decimals use 128 bits to store the 128 bits, 64 bits, yeah, 32 bits, yeah, 128 bits. I just realized in the last class I said bytes instead of bits. 128 bits, and they're like doubles. Doubles are 64 bits. They're like doubles, except for the precision is not there. They're not as precise. With decimals, we use decimals when we're dealing with numbers and interest rates and all that because it's very precise. The range isn't as high. With doubles, the range of numbers is much wider. You can go up to like 10 to the 308th power or something. With decimals, it's not quite that wide of a range, but with decimal, you get way more digits to the right of the decimal point. So if you're dealing with interest rates that are, fractions of a percent, you're dealing with trillions of dollars or whatever, you use decimal. There's explicit conversion where you actually say, I have this decimal number here, which is that value, but I want to be able to store it into an integer. So basically what you're saying, take this decimal number, whatever it is, convert it to an integer, which means hack off the digits to the right of the decimal point. And then, so that's what this does. And then store it into this integer variable. With doubles and decimals, you have to have a conversion because the double numbers have a wider range, so there has to actually be a conversion. But the ranges are different. And yes.
So the conversion from say decimals to integer, the decimals truncated?
Yes, I truncated. If you want to round it, there's a function for that. However, we can try it. I'm gonna do it here. So decimal Joe equals dun, 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 M, and integer Fred Fred equals int Joe. Message box Joe Joe to string, because you got to convert it, and then this is just another way to convert it, plus put a space there, plus Fred to string. see what this looks like. So when I click the button, it should display out that answer. Yes, so it just truncates. So these are various operators, mathematical operators. You should be familiar with these. Modulus is simply the remainder. Rules for performing calculations. You got to remember about operator precedence. If you want to go against operator precedence, you use parentheses. For example, in this case, if you did not have the parentheses, it would first divide B by 4, and then it would add the A, because division has precedence over addition. However, if we want to do the add first, then we put parentheses around the A plus B, and then it's going to do the A plus B first, and then divide by 4. In a calculation of mixed data type, the data type is the result. The data type of the result is determined by when an operation involves an int and a double. Int is treated as a double, and the result is a double. If the operation involves int and a decimal, int is treated like a decimal, and the result is a decimal. An operation involving a double and a decimal is not allowed. Integer division. When you divide an integer by an integer in C#, the result is always an integer. It's different in other programming languages. So when you have something like this, 7 divided by 3, they're both integers. So 7 divided by 3 is actually 2.22 1/3, but since it's the result's going to be an integer, the third is going to be hacked off, and it'll just be 2. So integer division. So if you want to avoid integer division and you want to get the the remainder, you want it to be 2.33333, then you can do this cast this type conversion here, and then so here we're actually taking the double value, a real number can have a decimal point x, so it does the conversion of x to a real number, conversion of y to a real number, then it does the division, and so then the result will be a real number. Inputting and outputting variables. Input collected from the keyboard is considered characters. So if you type in 1, 2, 3, 4, if you type in 25.65 into the text box, it's going to be the character 2, concatenated with the character 5, concatenated with the character decimal point, concatenated with 6, concatenated with 5. So this is 5 characters actually. So that's how it is in a text box. But if you want to convert that to a number, you use this parse, this int.parse, and that's going to convert it to an integer, which means it's just going to be 25. Here it's going to convert it to a double number, which it'll be 25.65, and decimal will also be 25.65. So if you want to read in a text box, and then you want to, it's a number, you want to treat it like a number, you use this int parse function, and this is the text box, is the text field of the text box, and then it's going to store it into an integer, and it's going to store it into a double. We're on 40. Okay, so displaying numerical values. The text property of a control only accepts literal strings. It only accepts strings. So if you try to write this number into a text box, it's not going to know what you're trying to do. So you have to convert it to a string first, and you do that by this toString method that you hook on stick onto the end of the variable here, and it converts it to a string 1550.0. It doesn't put the M on there. The M, if you want to think of what this thing, you think of M as money. You know, decimals is use decimals for money, and so M is money. That's the way I remember it. And you know, even integers. So I think did I show you this over here? I did. I showed this to you. I did the toString here. See, that's what I was showing you here. All right. Well, that's here. We're halfway through here. I think we spend 4 class periods on chapter 3. So so why don't it's 4:22. I think we've covered enough for today. So I'm not ready to give you a chapter 3 assignment yet. I wanna finish the slides first, and then I'm gonna have some good ideas of what I'll give you for an assignment. And so so you can work on the quiz. Are there any questions? Okay. So we'll see you on Thursday. Thanks for watching.